Welcome back to our chemistry lessons. This is lesson 4. Thank you so much, Kyaggwe TV, for hosting us. Thank you, dear learner, for subscribing to Kyaggwe TV. And thank you for doing that endeavor to see that education continues. I'm teacher Nsereko Huntington, your chemistry teacher. Today we're going to look at the oxides of carbon. Previously, we looked at the reactions of carbon, and basically the third lesson focused on the reduction reaction of carbon on metal oxides. Today we shall look at the oxides of carbon. Carbon mainly forms two oxides. It forms carbon monoxide and it forms carbon dioxide. Both oxides are gases. However, from the classification of oxides that you did in Senior 2, you learned that this one is an acidic oxide and then this one is a neutral oxide. So carbon forms two oxides, the neutral and the acidic oxides. We shall look at today, we shall put our attention on carbon dioxide. Carbon dioxide. Carbon dioxide is a common gas in the atmosphere. It is a colorless gas, denser than air, and makes about 60%, a density of about 60% higher than that of dry air. And it is a combination of two elements, carbon and oxygen. However, the two form a covalent bond during the formation of carbon dioxide. Two oxygen atoms covalently bond with carbon, resulting into a double bond. On your screen now, you can see the structure of carbon dioxide. It has two oxygen atoms. It has carbon at the center, and on either side, you could say sandwiched, but let's use some simple English. On either side is an oxygen atom. And where the circles intersect is what we call a bond. So carbon forms covalent bonds because the electrons are being shared, and we form carbon dioxide. Carbon dioxide is found in nature or in air, where it forms a fraction of 0.03% total composition. Plants require carbon dioxide to manufacture food, and other processes like fuel formation from fossil or fossilization, volcanicity, and respiration. When we burn the fossil fuels during the process of volcanic eruptions, if you follow closely, recently we had a volcanic mountain erupt in the Democratic Republic of Congo near the border with Rwanda. We have respiration taking place. I'm breathing out. The air that I breathe out also contains carbon dioxide. So those processes avail the gas in air. Now, let's look at the laboratory preparation of carbon dioxide.
Carbon dioxide in the laboratory. Put some marble chips like calcium carbonate in a round bottle flask fitted with a thistle funnel and a delivery tube. Place a collecting jar at the other end of the delivery tube. Pour dilute hydrochloric acid in the bottle through the thistle funnel so that the marble chips are covered with the acid. Effervescence takes place in the bottle flask and the gas is collected by upward displacement of air at the other end of the collecting jar.
In our video that is on the screen now, we will learn how to prepare carbon dioxide in the laboratory. Put some marble chips or calcium carbonate in a round bottomed flask with a system funnel and delivery tube. Place a collecting jar at the end of the delivery tube. Pour dilute hydrochloric acid in the bottle through the system funnel so that marble chips are covered with the acid. Effervescence occurs, and in the bottle a gas is collected by upward displacement of air or downward delivery in a collecting jar. This is how carbon dioxide is prepared in the laboratory. On your screen now from our video, there is a setup of apparatus. How do we set up the apparatus to prepare carbon dioxide? The apparatus is over there. It is simply drawn from the video we looked at. We put dilute hydrochloric acid in a system funnel, and in a round bottom, in a flask below, we put marble chips. Then we run the acid onto marble chips. Then the gas is collected and picked from there by the delivery tube and directed into a gas jar and collected by upward displacement of air or downward delivery. Why? Because carbon dioxide is denser than air. The equation of reaction is over there on the screen. It is hydrochloric acid plus calcium carbonate, we form calcium chloride, plus water and carbon dioxide. That is how we prepare carbon dioxide in the laboratory. Thank you for attending to our lessons. Thank you for watching Kyaggwe TV. Teacher Nsereko Andrew Hannington is your chemistry teacher today, and the lesson that we've just concluded, we have seen the oxides of carbon, and our focus was on carbon dioxide, and we looked at how to prepare it. We then wrote an equation of reaction. We welcome feedback. In case of any comments, please let us know. Where you think things are not doing well, please let us know. Even an upload is welcome. Don't miss next time in our lesson 5 here on Kyaggwe TV as we look at the uses of carbon dioxide. Thank you for watching. Thank you for subscribing. See you next time. Bye-bye.